Necessity is the mother of invention. And since the dawn of civilization, humankind has made incremental technological advances to make lives better for itself. From the mastery of fire to electricity and microelectronics, each development has transformed human society, economies, and daily life. Hi, you're listening to The Why in History. I'm your host, Ajay Kaul, and today we are talking about a history of technology from ancient times to the modern day. The invention of the wheel was one of the earliest and most impactful technological breakthrough dating back to around 3500 BCE in Mesopotamia. The earliest wheels were solid discs with a hole in the center and surprisingly were used as potter's tools. It would be at least another 300 years before the wheel would be used for transportation in carts and wagons. The use of the wheel in transportation opened up trade with different regions, which ultimately led to the advancement of agriculture, since it allowed the transportation of surplus to other markets and storage facilities. A point to note here is that there's also evidence that the wheel was independently invented in China. The wheel also found newer uses in other mechanical devices like grinding mills and gears. So one can say that the first engineering discipline discovered by humans was mechanical engineering. The wheel also boosted the strength of the military, with chariots becoming the cornerstone of warfare in ancient times. In the late 1970s, science historian James Burke posed a scenario in his TV series Connections. If civilization underwent a catastrophic end, but you were among the lucky survivors, where would you start? The answer was a simple yet transformative piece of technology: the plough. Invented around 3000 BCE, the plough was a transformative piece of agricultural technology during that time. And the introduction of the oxen-drawn ploughs was a complete game changer. Farmers could now till harder soils, and this expanded the available arable land. And this led to surplus agricultural output, which led to other specialist occupations because not everybody needed to be a farmer. Societies became more complex, and for the first time, the nomadic lifestyle was replaced by a settled one. Around 3000 BCE also was the discovery of the second branch of engineering, metallurgy. The Bronze Age was kicked off by the alloy that was made by mixing copper and tin. Copper had been used previously, but bronze was a technological leap as it offered superior strength and durability compared to pure copper. The process of making bronze included smelting of copper and tin ore in a furnace in a 90-10 proportion, melting them together in a clay crucible, and then mixing the molten metals before pouring the resulting alloy into a mold. After cooling, the cast object would be ground, sharpened, and finished to create tools, weapons, and items of jewelry. Bronze weapons and armor gave a significant advantage to armies and led to the expansion of empires. And this, in turn, led to the creation of nation-states. Civilizations like Mesopotamia, Egypt, and the Indus Valley became centers of metallurgical innovation. The metallurgical expertise was limited to a few, so the metallurgical engineers and craftsmen became very sought after. And because the demand for these metals was high, new trade networks sprung between these civilizations. Around 1200 BCE, the Bronze Age was followed by the Iron Age. Iron offered superior strength and durability compared to bronze and was more readily available And subsequently, the metallurgists started working on improving the iron production techniques. Iron played a crucial role in the rise of empires like the Roman Empire and the Han Dynasty in China. So, with the emergence of empires and nation states, things started happening at a massive scale. And that meant the third branch of engineering came into existence: civil engineering and architecture. Around the 4th millennium BCE, the Indus Valley civilization featured well-planned cities like Mohenjo-daro and Harappa, with organized streets, advanced drainage systems, and organized housing. But the ancient civil engineering marvel was the aqueduct, which was used to transport fresh spring water, utilizing a gentle gradient to the towns and the cities. The Greeks, around 6th century BCE, were the first to construct aqueducts, such as the tunnel of Eupalinos and the Peristratid aqueduct. But the Romans, around 300 BCE, improved upon the aqueducts structurally and built an extensive and complex network across their territories. Since it was meant for drinking, the Romans preferred freshwater sources like a lake or a spring and utilized gravity and the natural slope of the land to allow aqueducts to channel water from the source to the city. The water was used for drinking, irrigation, and in public fountains and baths. The Romans mastered the arch, which made the aqueducts more durable as well as visually appealing. The Romans also built an extensive network of roads which facilitated trade and movement of the military. The Roman concrete, though, was the fundamental building block of these amazing civil engineering and architectural marvels. The Romans used volcanic ash in their concrete, making it incredibly strong and resistant to weathering. Rome alone had around 11 aqueduct systems, which were supplying fresh water from sources as far as 92 kilometers away. And despite their age, some aqueducts still function and provide modern-day Rome with water. And because of this fresh water flowing in, ancient cities flourished with a healthy population. Were there layoffs in ancient times? Of course there were. And the first technology which led to mass layoffs was the watermill around 3rd century CE. The invention of mechanically driven milling technology decreased reliance on human labor in many sectors of the Roman economy. Essentially, the watermill used hydropower to drive the machinery. A continuous flow of water, sometimes from the aqueducts, drove paddles within the wheel with a lot of power, and this power led to the rotary motion of the wheel, which in turn was converted to the requisite motion of the machine via a combination of crankshafts and gears. And one of the earliest uses of the watermill was in the grinding of grain for the production of flour and bread on an industrial scale to feed the population. And to justify the watermill's construction costs, the early watermills were built in areas with concentration of people between 200 and 400. And when the population concentration was even greater than this, clusters of mills were built, such as the Janiculum mills in Rome in the early 3rd century CE. And slowly, the watermills expanded their use to other industrial operations. The stamp mills were used in mining to crush ore from deep deposits into small pieces before further processing, and the sawmill was used in construction to cut large amounts of wood or stone, thereby saving enormous amount of effort and labor. The watermills were the first harbingers of industrial automation in ancient times, and the reduction in time from the raw material to the finished product led to further population growth and more complex societies with new trades coming into play. Many of the principles used in the construction of these early machines are still applied to modern mill designs. When it came to spreading education through the masses, the most important invention in technology was the printing press, the invention of which is credited to German goldsmith Johann Gutenberg in 1436. The principle here was that small metal pieces with raised backward letters, known as movable type, were arranged in a frame, coated with ink, and then pressed onto a piece of paper. And that delivered a printed page. Repeating this process on many pages made up a book, and the same process repeated several times and swiftly led to the appearance of mass-produced books. Access to knowledge suddenly became universal. But about 200 years before Gutenberg's invention, Korea's Choi Yun-Yui invented the movable metal type printing technology to print a Buddhist text called the prescribed ritual text of the past and present in 1250. But roughly 400 years before the Koreans invented this printing technology, around the year 800, China invented the woodblock printing technology. This involved chiseling an entire page of text into a woodblock backwards, applying ink and printing pages by pressing them against this block. And around the year 971, printers in China produced a print of a vast Buddhist canon called the Triptaka, using 130,000 blocks. So why does Gutenberg get all the credit for the invention of the printing press? Primarily because Korea's printed books did not spread at the explosive pace that Gutenberg's books did 200 years later. Unfortunately, Korea was under invasion at that time, which hampered its ability to spread this technology within and to the outside world. One of the biggest impacts, though, of the printing press was that it led to massive scientific collaboration. Scientists could now publish their findings, spread it across the globe, and then collaborate with their peers towards making them technically feasible. What put Spain and Portugal to the forefront during the era of discovery starting 15th century? The simple answer: advanced sailing technology and instrumentation. Advanced sailing technology entailed the caravel, which was a highly maneuverable and fast ship, technologically enhanced by the Spaniards and the Portuguese. The caravel, with its lateen sail, was specifically designed for shipping and trade, as opposed to the other ships during that time, which served a dual purpose for shipping and military activities. The lateen sail was a triangular sail, and this allowed ships to even steer against the wind. And this greatly improved the speed and maneuverability of the ships at that time, making them a lot more effective for long-distance voyages. And once the explorers took off, there were two key navigational instruments adopted by these explorers: the magnetic compass and the astrolabe. The magnetic compass was invented by the Chinese around 300 BCE, but it was only around 11th century CE that the Chinese adapted it for navigation. And this technology reached Europe through the Islamic world by the 13th century. The magnetic compass helped the European explorers maintain a consistent and accurate direction during their voyages, and that was very crucial for long-distance travel. The astrolabe allowed sailors to determine their latitude by measuring the angle between the horizon and a celestial body like the sun or stars. And this was very critical for accurately charting a ship's position at sea. The astrolabe came to Europe from the Arabic world, and European scientists and craftsmen began making their own astrolabes by the 13th century. So between the caravel, the magnetic compass, and the astrolabe, voyages across the globe became faster, maneuverable, and accurate with respect to direction. New lands were discovered, new trade routes established, and it also kicked off an era of colonialism within Europe. What was the driving force that kicked off the Industrial Revolution? The answer: James Watt's steam engine. The steam engine was a groundbreaking development in the history of industrial technology. Steam engines had existed for a while, but during the 18th century, James Watt addressed the inefficiencies of the previous versions of the steam engine, most notable among these being the employment of a separate condenser, which conserved steam and reduced fuel consumption by approximately 75%. This specific innovation allowed steam to be condensed away from the cylinder, keeping it hot all the time. And this went a long way in improving operational efficiency. And James Watt continued with several other innovations to further improve the overall efficiency of the engine. Prior to the advent of the steam engine, factories were mainly powered by water or wind power, but these had several limitations. Both wind and water were constrained by geography and relied heavily on the environment, which was very unpredictable. But with all these constraints removed by steam power, the factory system rose, and so did mass production. Steam engines provided a reliable and a consistent source of power, and that allowed factories to operate on a much larger scale than ever before. As textile mills, iron foundries, and other industrial enterprises flourished, economic growth reached a new level, and the world witnessed rapid urbanization. Industrial cities like Birmingham and Manchester in England witnessed rapid development as workers flocked to them in search of employment opportunities. But how did the workers from the rural areas manage to reach these industrial cities? The answer: the other sector of the economy revolutionized by the steam engine: transportation. That is, railroads. Scottish mechanic George Stephenson was the chief mechanic at the Killingworth coal mine in England. There was a need for a more efficient and faster transport of materials within the coal mines, and that led to Stephenson building the first steam locomotive, the Blucher, in 1814 for the Killingworth coal mine. And this kicked off a revolution in the transportation sector. Steam locomotives enabled the rapid expansion of railways, facilitating trade and commerce on a national and international scale. Ships too became steam-powered, and this led to transatlantic travel becoming faster, more efficient, and connecting distant continents, which was previously unimaginable. The key change here was reliability. Ships no longer were at the mercy of unpredictable wind and weather conditions, and trains could run on a regular schedule. And as a result, factories no longer needed to be close to the source of the raw material or their end customer. The biggest impact, though, was on human mobility. Factory workers no longer needed to relocate near the factory premises. They could travel from their homes to the factory in a short amount of time reliably. This led to the growth of suburbs away from the factory premises where the workers tended to settle. People started traveling longer distances for trade, migration, and tourism. There was a greater exchange of ideas, cultures, leading to a more interconnected world. And on that note, we end this section of the program. On to the quiz section. Question from the previous episode. During the era of the License Raj in India, the officials of which multinational medical brand were summoned by the government of India for overshooting their authorized production capacity during a peak flu season? During a peak flu season in India, the sales of the entire line of Vicks cough and cold products shot through the roof. The factory worked overtime to meet the demand, and at the end of the season, The company declared record profits. Since their sales exceeded the production capacity authorized, the government of India issued summons to the Vicks management. The Vicks management, though, was able to present their case and prevent hefty fines from being slapped upon them. So the answer is C, P&G's Vicks Vapor Rub. Question for the current episode. Which was the most sought after brand of steel in ancient times? Was it A, Woods steel from India and Sri Lanka? B, Damascus steel from Damascus? C, Nordic steel from Austria and Slovenia? Or D, Chinese steel from China? Once again, which was the most sought after brand of steel in ancient times? Was it A, Woods steel from India and Sri Lanka? B, Damascus steel from Damascus? C, Nordic steel from Austria and Slovenia? Or D, Chinese steel from China? The answer will be provided in the next episode. That's all we have in the current episode. We meet again in 2 weeks with another interesting and exciting episode on world history. Till then, stay safe and keep exploring the why in history.